All right, so a complex number is written in the form A, this is an A plus BI, where A is the real part, BI is the imaginary part. So when we think of a typical real number, we think of, 7. And actually we could write that where its imaginary part 0. Or we could have a number like we were introduced to the other day. We said the square root of negative 16 is 4i, and that's pure imaginary, so how would I write that as a complex number? Well, its real part is 0. But there are numbers that have a real part and an imaginary part, and that's a complex number. In case you're wondering where in the world, would I ever use this? I know there are applications in electricity and all that kind of stuff. So maybe vectors, things like that. It's where you would, and that's physics, where you would use things. So we're talking about complex fields, I guess. And we also talked about the usefulness or the why you even have to have a complex number. Well, every quadratic equation's got to have 2 solutions because it's quadratic. Remember, the highest exponent of the equation tells you how many solutions there are. So if I have a cubic equation, the highest power is 3, then I ought to have 3 solutions. So in these solutions, here I have 2 solutions. Here I have one double root or double solution, like a perfect square trinomial factors into a binomial squared, so that one root happens twice. Or I have a problem like this one and this one where there aren't any real numbers that are solutions because they don't touch the x-axis at all, and the x-axis are the real numbers. So we had to have something to be able to give us an idea of the solutions, and so somebody came up with the complex number system, which I think we talked about here, which I is equal to the square root of negative 1. And then there's a pattern that forms, like I squared would be negative 1, I to the third is negative I, and I to the fourth is I. So if I said, what is I to the 15th? Okay, well, what is the multiple of 4 that is close to 15? 16, right? And so I to the 16th is the same thing as I to the 4th. I to the 16th was 1, so 15 is 1 less than that, so I to the 15th would equal negative I. This is just a pattern. So let me do another one, or several more probably. Let's say I to the 25th. What is a multiple of 4 that's very close to 25? 24. So I to the 24th would be equal to negative 1, and then the pattern starts all over again and goes back here. So I to the, this is supposed to be I to the 24th, y'all, I'm sorry. I to the 25th, that would be equal to I. Y'all see the first lap around over there where Riley is? Hey, Shane, close the door on your way out, please, ma'am, because it's cold in here. Okay, so let's look at, let's say I to the, 18th. Or I to the 18th. I could think of I to the 16th as close to 18th, or I could think 20th. Let's say I said 16, all right? So I to the 16th is the same thing as 1. And so 16, 17, 18, I to the 18th is the same thing as I squared, so that's equal to negative 1. You say, well, what if I said 20? Well, if I said 20 instead of 16, the same thing. If this is I to the 20th, which is 1, then here's 19, here's 18, it's still negative 1. What about I to the 7th? Well, here's 4. So here's 5, 6, 7. I to the 7th, the same thing as I to the 3rd, so that's equal to negative I. It's a pattern, and it goes in multiples of 4. So here's I to the 1st, I squared, I to the 3rd, I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, I to the 10th, I to the 11th, I to the 12th. Out of the 13th, 14th, 15th, 16th, it's a pattern. Okay? So what would be a multiple of 4 that's very close to 99? 100. So if this is out of the 100th, where's 99? One before that. Is this not simple? It's a pattern. All right, let's do a few more then. What is I to the 12th? Yes, it is a multiple of 4. 1. What is I to the 10th? Yeah. If here's 12, here's 11, here's 10. Out of the 27th. Here's 24, right? 25, 26, 27. Or you can say, oh, okay, well, a 28 is real close to that, so what's one less than that? So it is negative I. So it's just a pattern of 4, and you just have to think about that. All right. So now do y'all get this? I is not on the number line. It's not real. And pi is real, but it's just not rational. All right, so let's look at this. I have 2 complex numbers. How do I know? Well, they both have i's in them. And this is the real part of this complex number and this complex number. And this is the imaginary part of this complex number, the imaginary part of this complex number. Let me ask you a question about real numbers. What is the only thing that's equal to 7? 7. Are there other ways to write 7? Sure, 14 over 2, 21 over 3, 28 over 4. I could express them differently, but they're still what? 7. Okay? So if these 2 numbers are equal to each other, then it has to be true that its real part is equal to its real part, and therefore I can find x. And its imaginary part is equal to its imaginary part, and so I can find y. What's x? This is like an equation that a 5th grader could do, right? Divide both sides by 7. All right, here the i's cancel out, and I divide both sides by -2, and so y is -3. So if I have 2 complex numbers equal to each other, I just set the real part equal to the real part, and the imaginary part equal to the imaginary part. Well, okay, let's divide by I. Divide by 2i. Those would cancel, those would cancel, those would cancel. No, it has nothing to do with the pattern thing. I just divided, what's I divided by I? Same thing as 7 divided by 7, and 10 divided by 10, and 100 divided by 100. I divided by I is 1, right? Any number divided by itself is 1, even if it is imaginary. All right, solve for x and y. Remember, real is equal to real. Imaginary is equal to imaginary. Oh, goodness, I got a fraction. Yay, it's the right answer. Fractions are our friends. Now, if you prefer to write 3 1/3, that's okay. Good? Okay, ask me a question. You don't know how to find y? Okay. I'm looking for y, and I've got all this multiplied junk in the way, so I divided both sides by 3i. And those cancel out, and then 10 thirds, 10 divided by 3 is 10 thirds, and the i's cancel. The i's make it look weird, don't they? Because we're just not used to looking at them. All right, we can add, subtract, multiply, and divide with complex numbers. And here's how easy it is. Add the real to the real and the imaginary to the imaginary. Now this is in parentheses, and it would be, especially if we were subtracting, we would need to keep that in mind. But real to real, imaginary to imaginary. So 4 minus 1i. Combining like terms, really, isn't it? Huh? You good now? Okay. All right, what about subtraction? Well, you know how subtraction is. This sign changes the signs of those two. So minus a negative is a plus 2, and minus a negative is a plus 9i. So real to real, imaginary to imaginary, just like when you're combining like terms. The real part comes first, and then the imaginary part comes last. Negative 1 plus 1i. Combining like terms, even if they are weird. You know, square roots of negative 1. We still put them together. Okay? Now, it's called complex numbers, but they're not complex, not difficult. Imaginary is not really a fantasy either. All right, we can multiply them. What method do we normally use when we multiply two binomials? We did it on the quiz today. The full method. And so with this, we will use the full method. First, outer, inner, last. 2 times negative 5. 2 times negative 3i. I times negative 5. I times negative 3i. So I times I, y'all, is I squared. Now here's where we have to start thinking. What is I squared? Look at the pattern that you wrote down. What's I squared? It's negative 1. What is negative 1, which I squared represents, times negative 3? So this becomes a positive 3, not I, just positive 3, because I squared is actually the real number, negative 1. And so a negative 10 and a positive 3 would be negative 7 minus 11i. Now you'll get to where you'll just go straight to here. You'll think, okay, I squared is negative 1 times negative 3 is positive 3 and negative 10 is negative 7, and then we just put the i's together and got negative 11i. Be careful with your I squareds. Always see a negative 1 when you see I squared, and then it's a real number, and you can combine it with the other real numbers. All right, will you try this one? Full first, outer, inner, last. So that becomes a negative 16. And 30 minus 16 will be 14. And negative 24i and negative 20i make negative 44i. So don't think that sometimes people will put these two together and make this an I squared or something. Remember, when you're adding and subtracting, combining like terms, in other words, you don't change the exponent. So what do you think so far about adding and subtracting and multiplying? Not a big deal. I mean, basically it's the same simple math we already know how to do. We know how to combine like terms. We know how to use the FOIL method. All right, now let's talk about division. What does I represent? The square root of -1. It is the imaginary unit, but it represents the square root of -1. Okay, I can't have a square root in the denominator, agreed? Remember, we have to rationalize those. And I should really, before this time, have shown you this. So time out on this problem. You guys remember the word conjugates? We factored the difference of two squares into conjugates. Remember that? From last week. All right, fool these two out and see what you get. 3 plus 4i, 3 minus 4i. Fool those out and see what you end up with. What happened with the i's? They go away. They cancel each other out. That will always be true when you multiply conjugates of a complex number. You will get a real number. Okay, how does that apply to this division problem? Well, I need to know what I could multiply this by to rationalize it, to multiply by top and bottom, so that I would no longer have an I or a square root, which I is a square root of -1. I no longer have a square root in the denominator. So since I've just learned that to multiply conjugates gives me a real number, when on the bottom, this is a binomial. That's a lot of vocabulary I just said. What is a binomial? It's got how many terms? 2. If it's got one term, what do you call it? Monomial. If it's got 3 terms, you call it a trinomial. What are conjugates? They're binomials that are exactly the same except for their signs. Okay, and when you multiply them, you do get the difference two squared. All right, so what can I multiply this by top and bottom to get me a real number in the denominator? What would be the conjugate of 2 minus 3i? Yes. Now I got to keep this thing legal mathematically. So what I do to the bottom, I got to do to the top, because really all I'm doing, if you'll look at this, is multiplying this problem by 1 in a really sneaky way. Because what's anything divided by itself? 1. So I've multiplied this problem by 1 in a really different form, but I just used the conjugate of the denominator. Now I've got FOIL method on the bottom and FOIL method on the top. I've got to do first, outer, inner, last on the top. And a lot of lines here. First, outer, inner, last on the bottom. Since I multiplied by the conjugate of the denominator, what am I for sure going to get in the denominator? What did I get over here? A real number. That's why I did it. I can't, bless you, I can't have any radicals left. All right, so on the top, 2 times 2, 2 times 3i, 5i times 2, 5i times 3i. What's I times I? Yes. So I'm seeing a -1 when I look at that. All right, now in the denominator. First, outer, inner, last. 2 times 2, 2 times 3i, -3i times 2, Negative 3i times positive 3i. Negative 9i squared. And again, when I say I squared, I see negative 1. What would I have on the top now? I've got a negative 15 plus 4. Yes. If you said that, I just didn't hear it. Sorry. I understood. Okay. On the bottom, on purpose, I made it so that those would cancel. So negative 1 times negative 9 plus 4. 13. This is negative 15 plus 4. Right. I squared. When you see an I squared, see a negative 1. And you might say, now hold up, girl. I have not. You told me that a complex number has got real and it's got imaginary, and you didn't say anything about fractions. Guess what? A and B can be fractions, and that's okay. They share this denominator of 13. So the real part, come on, little pen. The real part is this, and the imaginary part's that. That's okay. We can handle 11/13 and 16/13. No, we're going to leave them just like that. A decimal with an imaginary number? That's just probably sinful or something. All right, let's keep on going. Let's try some more. All right, you do this one. You see what you can do. Yes, ma'am. It is. 11/13 is real, and 16/13 I is imaginary. Put them together, make me a complex number. It's okay that it's a fraction. Fractions are real numbers, you know. Don't discriminate just because they're ugly. You can't help it when you're ugly. It's just the way it is. All right, try this one. Rationalize. I've got an I in the denominator, so I've got to get rid of that. What do you suggest we rationalize with? Yes, the conjugate of the denominator. I like how in the time of trouble y'all call him the Lord. Oh, dear Jesus, I heard that. He knows about complex numbers. He does. All right, so did you fool? First, outer, inner, last. Be very careful with your signs here. First, outer, inner, last. And when you see that negative or that I squared, you're thinking about a negative 1. So this is 6 minus 4. And negative 8i and negative 3i. And this is minus a negative 1, which becomes plus 1, and 4 is 5. So this is 2/5 minus 11/5 I, if I write that as a complex number. All right, I need to work one that doesn't have a binomial on the bottom. Let's work one that has a monomial on the bottom. They're actually easier. What could I multiply by I to give me a real number? I. What is I times I? I. That's like a pirate. I. What is I times I? I squared, which is Negative 1. All right, so when this is a monomial, multiply top and bottom by I. Now, you got to do the distributive property up here, people. 3 times I, 2I times I, over 4I times I. What are those I squareds tell me? Negative 1. So what do I have? Well, I got to write my real part first. So what does this become? Negative 2. See how the real became imaginary and the imaginary became real on that? And then over what? Negative 4. You know what they normally do not do on any problem is leave a negative in the denominator. So if I brought that negative up, all it would do was change the signs of everything. This is the way that answer would be left. Now, by the way, if this number and this number and this number are all reducible, let's say for example, I end up with an answer where everything's even, I can reduce it. What would that reduce to? Yeah, it would. So on this sheet, operations with complex numbers and radicals, you are now ready to do 1 through 20. Believe it or not, you're ready. All right, now. She loves it. 1 through 6 is addition and subtraction. Guys, watch your signs and combine like terms. That's it. 7 through 12, you are multiplying. Oh my goodness, look at number 10. It is a binomial squared. What do you do with a binomial squared? You write it out twice and you FOIL it, right? All right, now, luckily for you, 13 through 20, you get to rationalize. Let me ask you a question. Look at 16. On 16, what would be the conjugate that you would multiply by top and bottom? Look at 16. Think about it for yourself. What would be the conjugate that we would multiply by top and bottom? Negative 6, what? Plus I. Notice I didn't change the sign of the first term. The conjugate is just a middle term, middle sign that you change. So on 16, you might want to write that down. You multiply top and bottom by negative 6 plus I. All right, feel free to work in a small group, with a partner, sit and cry by yourself and do it alone, whichever one.